environment like space and in a microgravity environment, it affects our body. So a couple of things that I want to talk about today. The first thing is, here is an astronaut. Right? His name's Drew Fuster. He spent 197 days on the International Space Station. Right? This is him when he came back. As you can see, he's struggling to walk. Now, there are two main effects that have occurred on his body. First one is his muscles have decreased and his bones have decreased as well. So this is a major problem for astronauts, but also us if we ever want to go into space or live there, potentially. So with muscles in a microgravity environment, what happens is they tend to decrease and waste away. With bones, similar thing. They become weakened and are easier to fracture as well. On short-term missions alone, 20% of our muscle and bone mass decrease. Long-term missions, 50%. Right, so we start to think about these things when we want to go to Mars, which is in about 10, 15 years or so. Right. So the solution to this is artificial gravity. Now, it sounds pretty weird and science fiction-y, but it's a possibility that could happen. Now, there are two ways that we could create this. The first way is by rotating a spaceship. Right? Some of you might recognise this is from The Martian, so they had this going as well. So by doing this, we create something called centrifugal force. Now, this force acts like gravity in a way that we'd be able to walk around the edges, like these ladybugs are, of a cylinder. So, like gravity is pulling me down at the moment, a centrifugal force would pull us to the edge. So it's a lot like if you've ever gotten a bucket of water and you've spun it really, really fast above your head. Has the water come out? Oh no. Right? It's stuck to the edges. Similar thing would happen here. There's one problem with this though, and it's called the Coriolis effect. This is when we misperceive our orientation and we start to get nauseous. Right? So this could be a major problem for us. I don't particularly want to be throwing up while in space. So another way we could do this is a human-powered centrifuge. This would occur in a similar way. We'd be creating that centrifugal force, but we'd be exercising and spinning at the same time. It's a bit of a dream, isn't it? Right, so the problem with this is that we can't be doing this for 24 hours a day. Right? Just like we can't exercise for 24 hours a day. So there are still problems here that we're still looking at and researching with this. But as long as you want your body to look the way it looks now, and I don't know about you, I'm quite happy with my muscles and bones at the moment. If we do tend to go up into space and stay there for a long period of time, we might look a lot like this. And I don't know about you, I can't imagine going out on a date with a blob. So where do we go from here? NASA is currently doing some tests on how we can adapt to a rotating environment, and it's actually significantly reduced the Coriolis effect, so no throwing up, which is great. So they're still currently doing tests on how we focus and how we do tasks in that type of environment as well. So this is a possibility for future missions, like I said with Mars, which I think we're hoping to do in 2020. I mean, it takes about 6 to 12 months to get there, so we're going to need to implement something like this, and for just future space exploration. Or us. I mean, if the Earth sort of goes downhill, we could go to space eventually and live up there as well. Yeah, thank you.